Python is the most popular programming language in the industry right now, and that is why people skilled in Python are highly sought after and highly paid. But the real question is, what does it take to crack that Python interview? Understanding the importance of Python, we have come up with this class on Python interview questions, which will cover the most common interview questions asked with respect to Python. Now, before we go ahead with the session, I'd like to inform you folks that we have launched a free learning platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below.
So we'll be starting off with our first question. What are variables in Python? So to answer this, whenever you're working with any programming language, you are basically working with data. And if you're working with data, you would have to store that data somewhere. And this is where variables come in. So you can consider these variables to be temporary storage spaces. Let's say you have a bunch of student names to store somewhere. Now what you'll do is you'll create a temporary storage space and you will go ahead and store the student names in this temporary storage space. So as you see over here, we have this value called as John, or the name of the student called as John. And if we want to store this value somewhere, we would need this variable. So I have created this variable called as student, and I am storing this value of John in this variable. And a variable has a name associated with it and a memory address associated with it. So as you see over here, this is the name of the variable and this is the memory address of the variable. And as I have told you, variables are temporary storage spaces, which means that once you store a value in a variable, it can be changed after a point of time. So here what I'm doing is I am starting off by storing this value John in this variable student. After some time, I decide to replace this value with this value of Sam. Again, after some time, I decide to replace this value of Sam with Matt. And this is how we can work with variables. Now let me go to Jupyter Notebook and show you how to create a variable. So I will start off by creating a variable called as A. And I will store this value of Sam inside this. Let me hit on run. And when I print out A, you would see that I have successfully stored this value of Sam in this variable A. Now, after some time, I would want to replace this value. So instead of storing Sam, I will have this value John inside this. And again, I'll go ahead and print out A. And as you guys see, I have changed the value of Sam to John. Now again, after some time, I would want to replace this to something else. So instead of having John over there, I'll have Matt. Now I'll print out A, and as you guys see over here, initially the name was Sam, then I have replaced the name to John, and finally I have replaced the name to Matt. And this is how variables work. Now that we know what actually a variable is, you'd also have to keep in mind that every variable has a data type associated with it. So we can have a lot of different data types. If you store integer values in a variable, then the data type will be int. So if you are working with numbers such as 10, 500, minus 27, minus 33, all of this would constitute as integer numbers, and this is what we are storing in this integer variable. Going ahead, we can also work with decimal numbers. So these decimal numbers are denoted with the floating point data type. If you are working with numbers such as 3.14 or 15.97, then these are basically what are known as floating point numbers. Going ahead, we have the Boolean values. And in Boolean values, we have only two of them, which are true and false. And you'd have to keep in mind that these two values, you don't have anything else, and these two are actually keywords. So what are keywords? We also have a question on that, so we'll look at that later on. And then we have another data type called as string. So whatever you have in single quotes, double quotes, or triple quotes, or when we are working with single characters, or when you're working with words, or when you're working with sentences or paragraphs, that is what is known as a string. Now let me go ahead and assign these different types of data into a variable. So I'll go ahead and start off by storing integer values. So let's say if I have this variable called as num1, I will go ahead and store this value 10 inside this. Now let me print out num1. And as you guys see, I am able to successfully store this value 10 inside num1. And if I would want to check the type of this variable, I will use this type method and I will pass in num1 inside this. And as you guys see, the Python interpreter tells us that this variable is of integer type. Going ahead, I will create another variable. Let me call it dec1, and in this dec1 I will store in the value 3.14, and I'll also print this out. Now if I would want to check the type of this, inside this type method I am passing in dec1, and you would see that the type of this variable is float. Now going ahead, I'll also create a boolean type. So I'll call it log1, and in this variable called as log1 I am storing this value true. And once I store this value, let me go ahead and check the type of it, and inside the type I am passing in log1. And as you guys see, I have created a variable bool, and this would store the value true inside this. And finally we have a string, so I'll create this variable called as str1, and inside this I will store this word called as Sparta. And if I would want to check the type of it, inside this I will pass in the variable name, which is str1. You would see that this is a string type variable, and this is how we can assign different types of data to our variables. We'll proceed to our next question now, and we would want to understand what are operators in Python. So primarily we have these different types of operators, which are relational operators, arithmetic operators, and logical operators. And as the name states, these operators help us to perform different types of operations on the data which we are working with. So we'll start off with arithmetic operators in Jupyter Notebook. Let me just add a comment over here. I will have arithmetic operators, and I will start off by storing the value of 10 in this variable a. Then I will go ahead and store this value of 20 in this variable b. Now that I have stored these two values, I would want to perform some basic arithmetic operations. So what are the different arithmetic operators we have? We have plus, then we have minus, then we have multiplication, then we have division. And division is denoted by a /. So these are the different types of arithmetic operators we have. So if I would want to perform addition operation, I'll just have a plus b over here, and as you see, I have successfully added a plus b, which is 10 plus 20, and I get the result 30. Similarly, if I would want to subtract two numbers, I will have a minus b over here, and as you see in the result, I get minus 10 because 10 minus 20 is minus 10. Then if I would want to multiply two numbers, I have a into b over here, and when I run this I get the value 200 because 10 into 20 is equal to 200. And then finally I have the division operator. So for the division operator I will use the / and I will have a divided by b, and this time I will get the result 0.5 because 10 divided by 20 is 1/2, which is equal to 0.5. So these are the different types of arithmetic operators which we have. Going ahead, we will work with relational operators. So I will just write down relational operators over here, and we'll be working with the same two variables. I will have a and b over here. I'll print them out for your sake. So 10 is stored in this variable a and 20 is stored in this variable b. Now these relational operators help us to find out the relationship between these variables. So if I would want to understand if one variable, or if the value of one variable is less than the value of another variable, or if the value of one variable is greater than the value of another variable, these are the different types of operations which you can perform with the relational operators. So I will just go ahead and type a greater than symbol b. I want to check if the value which is present in a is greater than the value which is present in b. I get a false value because obviously 10 is not greater than 20. Then I would want to check if a is less than b. This time I would get a true value because 10 is absolutely less than 20. Then I have the double equal to operator, which would help me to check if the value in a is equal to value in b. And you would see that I get a false because obviously 10 is not equal to 20. and then finally I would want to check if the value which is present in A is not equal to the value which is present in B. So I shouldn't give this space over here, and this time I get a true value because 10 is not equal to 20. And these are the different types of relational operators which we can work with. Going ahead, after the relational operators, we would have the logical operators. So I will just write down logical operators over here. Now we have only two logical operators, which are AND, OR. AND is represented with this symbol over here, and OR is represented with this particular symbol over here. And we will start up by working with the AND operator. And the AND operator gives us a true result only when both of the operands are true. So for this, I will have A and B again, but this time I'll be storing the value true inside A, and I will be storing the value false inside B. Now that I have created these two new variables, what I would want to do is I would want to check A and B. And when I check A and B, what do you think would be the result? It would be false, because I've told you will get a true result only when if both of the operands are true. So here A and B would be equivalent to true and false, and true and false would be obviously false. Then let me try out B and A. So when I have B and A over here, again I'll get a false, because false and true is also false. Going ahead, I would want to try B and B, which is false and false, and obviously false and false would be equal to false. And then finally let me check A and A, and this is the only case where we'll be getting true because both of the operands are true. And this is how the AND operator works. Now let me go ahead with the OR operator. And this OR operator would give us a true result when either of the operands is true. So we'll have these same variables over here, and let me start off by checking A or B. And when I check A or B, I get the true result because true or false is equal to true. Then if I go ahead and check B or A, I will again get a true result because false or true is obviously true. And then finally when I have A or A, this again is true because true or true is true. And the only case where I'll be getting a false is B or B, which in other words is false or false. These are the different types of operators which we have. Next question is, what are the different types of tokens in Python? So you can consider tokens to be the smallest building units in a Python program. And the different tokens are keywords, identifiers, literals, and operators. We have already worked with operators, and we have seen that we have arithmetic operators, we have relational operators, and we have logical operators. And with these, we can perform simple operations on the data which we have. Then we have something called as keywords. So you can consider these keywords as reserved words. Now when I say reserved words, what I basically mean is you cannot use these words for anything else apart from the purpose they are there in Python. So you can't give the names of variables or names of functions or names of classes with these keywords. And these are the different keywords which you have. We have false, if, def, try, while, and so on. Let me just give you some examples of these keywords in Jupyter Notebook. Now, when I write DEF over here, you would see that the text color automatically turns into green. And let's say if I try to store something in this, so when I have while, and if I try to store the value 10 inside this while, I get an error which is invalid syntax because I cannot store a value inside this keyword. If you have a keyword, you cannot store a value inside that keyword. Then we have something called as identifiers, which are used for giving the names for variables, functions, or objects. And these are some basic rules for identifiers. So these identifiers are case sensitive, which would mean that if you would create a variable with, let's say if it is var, and if you have a variable where v is small and if you have a variable where v is capital, both of them would be different. I'll just show you the example for this again. Let me go ahead and create a variable called as var1 and I will store the value 10 in this. Then if I go ahead and create a variable called as var1 where v is capital, and this time I am storing the value 20 inside this. Now when I print out var1 with small v and var1 with capital V, you would see that I get 10 and 20. So Python interpreter deals both of these variables as different. So var1 with small v is different and var1 with capital V is different for the Python interpreter. Then we have literals. Literals are just values which you store into the variables. So when you say a equals 10, here a will be the variable and 10 will be the literal. So that's all about the different types of tokens. Now we will understand what are strings in Python. So the question is, what are strings in Python? So to answer that, strings would be whatever is enclosed in single quotes, double quotes or triple quotes. And normally a string can be a single alphabet, it can be a word, or it can be an entire sentence, or it can be even be lines of different paragraphs what we have. And let me go ahead and show you some examples of strings. I'll start off by creating a simple string with single quotes over here. I'll have str1, and what I'll do is I'll just store the letter A inside this. I will print out str1 and we have created our first string. Then I will go ahead and create str2 and I'll create this string with double quotes, and this time I will have the word Sparta stored inside this. Then let me print out str2 and you would see that I have created the next string. Now let me create a multi-line string, and to create a multi-line string I would require triple quotes. So I just have given triple quotes over here and I'll just write down I love Python. Let me run this and let me print out str3 for you guys. And what you see over here is we have /n/n, which would mean we have two new lines, and at the third line we have I, as you see over here. Then again after I we have a /n, which would mean we have the next line, and in the next line we have the word love. Again we have a new line, and in the new line we have the word Python. And now we will also see how to extract some individual elements from this Python string. So in a Python string you would have to remember that the indexing starts from 0. So the index of this will be 0, index will be 1, 2, 3, 4 and 5. And if I would want to extract the first character from this entire string, I would have to give the name of this string, and in parenthesis I would have to give the index value. So when I given 0, this would mean that I am basically extracting the first character from the string, and as you guys see over here, my string 0, I am extracting this character from this entire string. Now similarly, if I would want to extract the last character from this entire string, I would have to give in -1. So if I give in -1, you would see that I am able to extract the last character from this entire string over here. Let me create a new string. I will call this string as my string, and I will just write down I love Sparta, and let me print this out as well. So I will have my string, and once I create the string for you guys, if I would want to extract the first character, we already know that the first character is present at index number 0. So I will have my string and I am passing an index number 0, and as you guys see I am able to extract this first character. Similarly, if I would want to extract the last element, so the index of last element will be -1. So I will have my string, this has to be small over here. Keep in mind that Python is case sensitive, and I will give an -1 over here, and as you guys see I am able to extract this last letter from this. Heading on to the next question, what are the different data structures in Python? So we have tuple, dictionary, list and set. So we will start up by understanding what exactly is a tuple. You can consider a tuple to be a collection of elements, and it is an ordered collection of elements, and a tuple is immutable. What do I mean when I say a tuple is immutable? This basically means that once you add some elements into a tuple, you cannot change or modify those elements. So let's go to Jupyter Notebook and let's see some examples with a tuple. So I will just have tuple over here. And what I'll do right now is to create a tuple, I'll write down the name of the tuple as tup1, and to create a tuple we would have to give this round braces, and we can have heterogeneous elements stored in this tuple. When I say heterogeneous elements, I would mean that we can have elements of different data types. So I will start off by storing this number 1, then I will store a logical value true, then I will store a string value a. Now let me print out tup1 over here, and as you guys see, I have successfully created this tuple where I have these elements. And just to check the type of this, I have type method, and inside this I will pass in tup1 over here, and you would see that I have successfully created a tuple. Now if I would want to extract a particular element from this tuple, so I can do that by giving the index value. So I'll have tup1 and in parenthesis, if I would want to extract the first element is present at index number 0, and you would see that I have successfully extracted this. So this is how you can extract elements from this. But I have told you that a tuple is immutable, which basically means that once you create a tuple, you cannot modify it. So let's say I have these 3 elements, and if I want to change this element from 1 to 100, then let me try it out. So I'll give index number 0 over here, and I will try to store the value 100 inside this, and you would see that I get an error, and the error states tuple object does not support item assignment because a tuple is immutable. Now after this we will go ahead to the next data structure in Python, which is a list. So the difference between tuple and list is, while a tuple was immutable, a list is mutable, which means that once you create a list, you can either add new elements or you can modify the existing elements which are present in the list. And also you create a list using square braces. So let me create this list called as L1, and inside this I will store in a bunch of values. I'll start off by storing this number 1, then I will have this logical value true, and again I will have this value a over here, and I will print out L1 for you guys. And now that I have created this list, let me check the type of this. So I have type, and inside this I will pass in L1, and as you guys see, I have successfully created this list. And the extraction of elements from a list is same as a tuple. Now let's see if we can actually modify this tuple or not. So I would want to modify this value which is present at index number 0. I would want to change this from 1 to 100. So I'll have L1, and in the index I'll give in 0, and I would want to change this value to be equal to 100. Now when I print out L1 over here, you would see that initially the value over here was 1, and I have successfully changed this value to 100. I can also add a new value if I want to this. So initially I have 3 elements and the index for this is 2. If I would want to add a new element, I will just give in this. So 0, 1, 2, the new element would go at index number 3, and over here I would want to add the word Sparta. So we actually get an error over here, list assignment index out of range. So seems that we can only add elements which are in the index. But if I would actually want to add a new element, let me see if I have some other method over here. L1.add, I will have Sparta over here, and we don't have the add method as well. Let me try it out with the append method over here. And we see that we have successfully added the Sparta word over here. Now let me actually print out L1, and you would see that this time we have added a new element at the end of the list. So not only can you modify the existing elements which are present in a list, you can also go ahead and add new values into the list with this append method. And you'd have to remember that you can't add new elements with the index, but you will have to use this append method to add in new elements. So this was about list. Now we will head on to our next data structure, which is a set. So a set is an unordered collection of elements. Now when I say unordered collection of elements, you can't access those elements with an index, because when you create this set, all of those elements will be randomly stored at different index positions. And also duplicates are not allowed in a set. So let me just show you guys an example of a set over here. I'll have S1, and to create a set we will be using curly braces. Let me have some repeats over here. So I'll have 1 occurring 3 times, then I'll have 2 occurring 2 times, then again I'll have 3 occurring 3 times, and I will print out S1 over here. So as you see, even though I have duplicates or repeats present in this set, I have printed them only once. So this would mean that a set only takes in unique values. And then let me go ahead and check the type of this. Inside type, I will pass in S1, and as you guys see, this would tell us that I have successfully created this set. Now, as I have told you, we cannot access index elements of a set. So let me try to access over here. So I'll have S1, let me have 0 over here. And as you see, set object is not subscriptable, which would mean that indexes are not present for a set and you can't directly access the elements with the help of this index. Going ahead, we have the next data structure in Python, which is a dictionary. And you can consider this dictionary to be a collection of key value pairs. So I'll just show it to you how to create a dictionary. Let me have the name of this dictionary as D1, then I'll have these curly braces over here, then I'll have a key value pair. I'll have the first key to be called as K1 and I'll store the value 10 inside this. Then I'll have the next key to be equal to K2 and I'll store the value 20 inside this. And I'll have the key K3 and I will store the value 30 inside this. So I have created this dictionary. Let me also print out D1 over here for you guys. And as you see, we have these key value pairs. So this is the first key value pair, K1 and 10. Then we have the next key value pair, K2 and 20. And then the third key value pair, which is K3 and 30. And just to check the type of this, I will use this method. I will pass in D1 inside this. And as you guys see, we see that the Python interpreter finds this object as a dictionary. Now, if you want to access the keys and values individually, we can just go ahead and use the keys method. So when I have d1.keys, you would see that I have successfully extracted all of the keys from this dictionary. Similarly, if I would want to access the values, I will have d1.values over here, and you would see that I have successfully extracted all of the values. So these are the different types of data structures which are present in Python. So we have the next question over here. What can you tell about object-oriented programming in Python? And this is a very interesting question. So Python is an object-oriented programming language, but what does it mean when we say we have an object-oriented programming language? Well, the answer is very simple. Now, when you look around you, what do you actually see? You would see that you are surrounded with objects, aren't you? The laptop which is present in front of you, that is an object. The phone which is there in your hand, that again is an object. The water bottle which is placed beside you, that again is an object. And if you want to represent all of these real life entities in the programming world, we would require an object-oriented programming language. And there are two important components of object-oriented programming, which are classes, and obviously we have objects. Let's start off by understanding what exactly is a class. You can consider this class as a template or a blueprint for real world entities. Let's say if we consider this phone or a mobile over here, and we call this phone or mobile a basic template. Now, this class or this basic template will again have two things with it. The first property, we have something known as a property, then we have something known as behavior. So a phone will have certain properties associated with it, which are a phone will have a color associated with it, a phone will have certain cost, and a phone will have a certain battery life associated with it. These are all of the properties. Then we also have certain behavior which this phone will have. So with the help of this phone, you can make calls. With the help of this phone, you can watch videos. And in this phone, you can even play games. So these are the properties and this is the behavior which you can associate with this general template. Now that we know what exactly is a class, let's understand what are objects. So you can consider these objects to be specific instances of a class. So if we call this mobile or this phone as a class, then the objects of this phone class will be Apple, Motorola and Samsung. So all of these would be objects of the phone class, and these objects would have the properties and behavior of the phone class. So with the help of this Apple phone, you will be able to make calls, you will be able to watch videos and you will be able to play games. Similarly, this Apple phone will also have a color, it will have a cost and it will have a battery life associated with it. So this is all about the theoretical side of object-oriented programming. Now let's actually see how can we create a class in Python. So to create a class in Python, we will be using this class keyword and then we will give the name of the class. So here, as you see, I have given the name of this class to be equal to phone, and inside this I given def, which is I am creating a method over here and I am creating these two methods called as make call and play game, and I am setting the behavior of this phone. So inside the make call method, I'm just printing out making phone call, and inside the play game method, I'm just printing out play game. And now that we have the template or the class ready, we can go ahead and create an object of this class. So here I am creating the object by using this syntax over here. I have p1 is equal to phone. So this is how I am instantiating the p1 object. And now that we have the object of this class, I can go ahead and invoke the methods which are present in this class. So when I have p1.makeCall, I am successfully printing out making phone call. Similarly, when I have p1.playgame, I am printing out playing game. Now let's go to Jupyter Notebook and implement these simple things. So I will have object. Let me write this out as oriented programming. Now that I have added this comment, it's time to create a class. Let me just create some space over here and I'll start off by writing the code from over here. I would have to give in the keyword class, then I would have to give in the name of this class, and by convention, remember, the first letter of this class has to be capital. Now I'll give in colon over here and I will give in the methods which I want to be a part of this class. So I will write down def because this is how we create a method or a function, and I will create a method called as play game. And this takes in only one parameter, which is self, because this would help us to access the attributes or the methods with the help of the object. Now this will have a simple print statement, and with the help of this simple print statement, I'll just print out I am playing a game. We have our first method ready. Now we will go ahead and create our second method, and we will call that second method to be make call. This again will only have one attribute, which is self, and I'll have the print statement over here again, and I will write down playing a game. We have created this class. Now we have to go ahead and create an object of this class. I will have, so here I will have p1 is equal to phone. And now that I have created this object, I can invoke the methods which are present in this object. So here I will have p1.playgame, and when I run this, you would see that I have printed out I am playing a game. Then I will have p1.makeCall, and this time when I run this, you would see that I am printing out. I would actually have to change this. So make call, let me change this to making a call. And now when I invoke this method, you would see that I have successfully printed out making a call. And this is how we can create a class, and we can invoke the methods or the attributes which are there in the class with the help of the object. But here, as you see, we haven't really added anything. We haven't really added any attributes in this phone class. So now what you will do is we'll add certain attributes, as we had seen in the theoretical section, that maybe your mobile will have a color associated with it and a cost associated with it. So what I'll do is I will assign the color and cost with the help of this methods. So I'll delete this part again over here. Let me cut this out over here. I will remove this object. And now in this class, I'll be adding 4 more methods. I will add one method to assign a color to this. So here I will have def. I will name this method as assign color. This will definitely have the self parameter, and after the self parameter I will add an additional parameter called as color, and I am assigning this value to the color attribute of the phone. So here I will have self dot color is equal to color, and this is how I'm assigning a value. Now going ahead, I will have another method to assign cost to this phone. So here I will have assign cost, and over here again I'll have self and I'll have cost over here. Now that this is done, I would need to have self dot cost is equal to cost, and I have created these two methods. And after this I would have to create another method, and I will call this method as show color. So we have assigned the value of color, we have assigned the value of cost. Now it's time to show those two values. So I will have a method called as show color, and this takes in only one parameter, which is self, and I will return out self dot color. Similarly, I would need another method to show the cost as well. So I will have show cost over here. This takes in one parameter, which is self, and I will go ahead and return self dot cost. So I have added these 4 methods over here. Now I'll create again this object called as p1, and I'll instantiate it. Now after instantiating it, I will be assigning values like this. So I will have p1 dot assign color, and let me set the color of this to be equal to blue. Then I will also set the cost over here. I will have p1 dot assign cost, and inside this I am setting the cost to be equal to $100. And after this I would have to show the color and show the cost. So here I will have p1 dot show color, and going ahead I'll also show out the cost. Here I will have p1 dot show cost. So as you see, we have successfully assigned some values, and we have also printed out those values. We have our next question: what is inheritance in Python? So we can relate the concept of inheritance to the real world inheritance. So let's say you inherit your features from your parents. Similarly, your parents inherit their features from their grandparents. And this is the same analogy we can associate with inheritance in Python as well. So what happens in inheritance is we will have a child class and we will have a parent class, and the child class will be inheriting some features from the parent class. So either it can inherit only some of the features, or it can inherit all of the features from the parent class. So here we will start off by creating the parent class. We have this vehicle class over here, and inside this vehicle class we have this constructor, and with the help of this constructor I am assigning the value for mileage and cost. And once I assign the values, I just go ahead and show out the details. So I am printing out I'm a vehicle, mileage of the vehicle is this, and cost of the vehicle is this. And once I create the template of this, I create an object of the parent class over here. And since I have a constructor, I can initialize the values for mileage and cost directly when I'm initializing this object itself. So here I have v1 is equal to vehicle 500, and I'm setting the value of mileage to be equal to 500, and I'm also setting the cost of this vehicle to be equal to 500. And when I invoke the show details method, you would see that I have printed out I'm a vehicle, mileage of the vehicle is 500, and cost of the vehicle is 500. Now let me go to Jupyter Notebook and work with these. So I will just write down a new comment over here, and I will write this comment as inheritance. In Python, we would have to start off by creating this new class. Let me delete whatever was present over here, and I'll just have a new class over here, and I will call this class as vehicle. And inside this vehicle class, what I would want is I would start off by creating a constructor. So I have def, then I have the init method, and inside the init method I would definitely need this self attribute over here. Then this vehicle will have certain mileage associated with it, and this vehicle will also have certain cost associated with it. And all I'm doing inside this constructor is setting the value for mileage and cost. So I will have self dot mileage is equal to mileage, and after this I will have self dot cost is equal to cost. Now that I have created this constructor and I have assigned the values, I can go ahead and also show out the details. So I will have def, then I will create this method called as show vehicle details, and this takes in only one parameter, which is self over here. And I will start off by printing out I am a vehicle, and after that I would want to print out the mileage. So here we will have mileage of the vehicle is, and here it will be self dot mileage. Then we will have this print statement again, and over here we will have cost. So I'll have cost of the vehicle is, and here I will have self dot cost, and this is how I am creating this template for this vehicle. And once I create this template, I can create an object of it. So I will have v1 is equal to vehicle, and inside this I'll pass in the values for the mileage first. So let's say this vehicle would give me around 100 miles per gallon, and I would set the cost of this vehicle. So let's say the cost of this vehicle is around $999. We have created this object, and since we have a constructor, we have also assigned the values. I can directly go ahead and invoke this show vehicle details method. v1 dot show vehicle details, and when I hit on run, you would see that I have printed out I'm a vehicle, mileage of the vehicle is 100, and cost of the vehicle is 999. So we have our parent class ready. Now that we have created our parent class, we will go ahead and create our child class. So to create a child class, the syntax is same. We'll have class of car, and over here, so initially when we had created a class, you would see that we don't have parenthesis, but during the time of inheritance we'll have this parenthesis, and inside this we will give in the name of the parent class. And as you guys see, this car class is inheriting from the parent class vehicle, and this child class will have its own method, which is show car, and with the help of this I am just printing out I am a car. Now when we create an object of this child class, you will see that I am passing in the values for 200 and 1200. Now even though we don't have this constructor, so this constructor is part of the vehicle class but not part of the car class. So even though this constructor or init method is not part of the car class, but since this car class is inheriting the vehicle class, that is why we can directly pass in the values of 200 and 1200 while instantiating the object of this car class. Then as you see, even though we don't have the show details method inside this car class, but since this car class is inheriting from the vehicle class, we are able to invoke this method of the parent class. And when we print this out, these are the details which we get. And we also have an explicit method which is only to this car class. We have this show car method, and we can directly invoke this obviously. So when I have c1.showCar, you would see this result, I am a car. Now it's time to create the child class over here. So to create the child class, I'll just write down this keyword class over here, and I will give in the name of this class, which is car, and this will be inheriting from this vehicle class. And once this inherits from this vehicle class, I would have to create a new method of its own, and I will call this method as show car details, and this will only have the self attribute, and inside this we will only be printing out I am a car. We have created the child class as well, and we can go ahead and create an object of this child class. So we will have C1 is equal to car, and since this is inheriting from the vehicle class, this will have a mileage value and a cost value. So this time I will set the mileage to be equal to 70 miles per gallon, and I will set the cost to be equal to around $12,000. So seems like an expensive car, but the mileage what it gives is extremely low. So we have created this object. Now I can go ahead and invoke the method of the parent class. So here I will have C1 dot show vehicle details. I'll keep this as small d over here, and when I hit on run, so this has to be underscore and not a period over there. And as you see, I'm able to invoke I'm a vehicle, and since I've passed in the values of 70 and 12,000, you would see that the mileage of the vehicle is 70 and the cost of the vehicle is 12,000. And since we have a single method which is there in the car class itself, I'll go ahead and invoke that. So I'll have C1 dot show car details, and I'll keep it to be small d over here, and when I hit on run, you would see that I get the result I am a car.
We have our next question over here. How can we initialize a NumPy array comprising of only zeros? So for this, we'd have to start off by importing this library called as NumPy. We will have this command import NumPy as NP. And with this library, we'll have a method called as zeros, and we'll be using np.zeros. And over here, we will pass in the dimensions of the NumPy array. So I am creating a 1 cross 2 NumPy array, and that is why I will give in the values 1, 2. I will store this in this variable called as n1, and this is what I get. And this is how I am printing out a NumPy array of dimension 1 cross 2 where the values are only zeros. Similarly, if I would want to create a NumPy array of dimension 5, 5, and if the values have to be zeros, then I will have np.zeros, and inside this I will pass in 5, 5, and when I print this out, you would see that I have a NumPy array of dimension 5 cross 5 and all of the values are equal to 0. Let me go to Jupyter Notebook and print this out for you guys. My first task would be to go ahead and import this library. So I will have import NumPy as NP. Let's just wait for this library to load. Now that this is done, I would have to use the zeros method. So I will have zeros, and I will give in 2 round braces over here, and I would have to give in the dimension. So if I would want to create a 3 cross 3 NumPy array, so I'll give in 3, 3, and I will store this in this object called as n1. Now let me print out n1, and you would see that I have successfully created this 3 cross 3 NumPy array where all of the values are equal to 0. Now similarly, instead of 3, 3, if I would want to create, let's say, a 5 cross 6 NumPy array, what we'll do over here will be same. So we will have np.zeros over here, and I will pass in 5, 6, and this I'll be going ahead and storing in a new object called as n2. Now if I print out n2 over here, you would see that I have 1, 2, 3, 4, and 5. I have 5 rows, 1, 2, 3, 4, 5, and 6, and I have 6 columns. So I have created a 5 cross 6 NumPy array where all of the values are equal to zeros. We have the next question. So this time the question is, how can you initialize a NumPy array with random numbers within a particular range? And for this purpose, we have a method called as randint. And this again is a part of the random submodule.
So here we will have np.random.randint, which will help us to generate random integers within a particular range. And as you see over here, we have three parameters. The first parameter is the starting value of the range. The last parameter is the ending value of the range. And the third parameter is how many numbers do we want? How many random numbers do we want in this particular range? So the range is between 1 to 100, and I would want 5 random integers between or in the range of 1 to 100. And as you see over here, I've got these numbers 95, 88, 26, 22 and 76, which are 5 random numbers which have been generated with the help of this method. So here I will just write down np.random.randint, and I'd have to give in three parameters. Now let's say if I would want random integers between the range of 250 and 500, I'll give in 250, which is the lower limit. Then I will give in 500, which is the upper limit. And let's say if I would want 50 random numbers, I'll give in 50 over here. Now if I just hit on run, you would see that I have 50 numbers. Let me just verify this. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This will be 26. This will be 39. 40, 41, 42, 43, 44, 45, 46, 47, 48, 49 and 50. So as you guys see over here, I have 50 random integers which are in the range of 250 to 500. So if you look closely, you would see that all of these numbers are between 250 and 500. None of these numbers are less than 250 and none of these numbers are greater than 500. Next up, we have a question where we are supposed to know what is vstack, headstack and column stack. So these different methods are part of the NumPy library again, and these would help us to stack two NumPy arrays with each other. Let's start off with the first method, which is vstack, and with the help of vstack, we can, as the name states, we can stack one NumPy array on top of another NumPy array. So here we are starting off by creating two NumPy arrays. In N1, we are storing the values 10, 20 and 30. In N2, we are storing the values 40, 50 and 60. Then when I use the vstack method, as you guys see over here, in vstack, I pass in N1 and N2. And as you guys see, I have vertically stacked these NumPy arrays. So in the first row, I have 10, 20 and 30. In the second row, I have 40, 50 and 60. Let me just go ahead and start off with vstack first. So I'll just give in a comment over here. I'll write down vstack. I'll create two NumPy arrays. I'll have n1 np.array, and inside this I'll just have 1, 2 and 3. Then I'll have n2 as well, and then n2 I will have, let's say, a list comprising of the numbers 4, 5 and 6. And now that I have created these two NumPy arrays, I'd have to vertically stack them. So I will use np.vstack, and the first parameter will be n1 and the second parameter will be n2. And when I run this, you would see that I have vertically stacked these two NumPy arrays. Then we have headstack. And headstack, as the name states, we will be horizontally stacking two NumPy arrays. So we have the same NumPy arrays over here, n1, 10, 20 and 30, n2, 40, 50 and 60. And this time when I use headstack, you would see that I have horizontally stacked n2 at the back end of n1. Or in other words, I can even say that I have appended the n2 NumPy array at the back end of n1 NumPy array. And this is the entire result over here. So what I'll do is, we'll take the same NumPy arrays, and instead of having np.vstack, I'll just do a minor change over here, and I will have np.headstack. And this time, as you see, I have 1, 2, 3 and 4, 5, 6 appended at the back end of 1, 2 and 3. Then we have our final stacking method, which is column stack. And again, as the name states, column stack helps us to stack two NumPy arrays in two individual columns. So if I have np.columnStack n1, n2, you would see that in the first column I have the n1 NumPy array, and in the second column you would see that I have the n2 NumPy array. So now all I have to do is change this method from head stack to column stack. I'll just write down column stack over here. Now when I hit on run, you would see that I have successfully stacked these two NumPy arrays in two adjacent columns. We have the next question where we are supposed to create a panda series object. So panda series object, as you see in the question itself, it is part of the pandas library, and we can create this object like this. So we'd have to start off by importing the pandas library. So we would have to write an import pandas as pd. Then we will be using the series method. So we'll have pd.series, and you'd have to keep in mind that s has to be capital over here, and inside this we are passing in a list of numbers which are 1, 2, 3, 4 and 5. And when I print this down, you would see that this is what I have. And finally, when I check the type of this, so type of s1, I see that this is a pandas.core.series.series object, or in simple words, it is just a series object which I have just created. So I will add another comment over here, and I'll name this as pandas. And I would have to start off by importing the library. I will have import pandas as pd. And now that I have imported this library, let me just wait for this to import. Now I can go ahead and create the series object. I will have pd.series. And inside this, again, I'll just pass in a list of values. I will have 1, 2, 3, 4 and 5. And I'll go ahead and store this in an object called as s1. And I will print out s1 over here. And you would see that I have created the series object. Let me also check the type of this. And in the type method, I'll be passing in this s1 variable. And as you guys see over here, in the type, this is of pandas.core.series.series. Next up, we have a question with respect to visualization with the matplotlib library. And we are supposed to create a line plot using this matplotlib library. So we'd have to need two libraries over here. First, we'll be creating the data with the help of the NumPy library. And since we'd have to make a line plot, we would obviously need matplotlib. And there's a sub module called as pyplot. So the command will be from matplotlib import pyplot as plt. And plt is the alias which we'll be giving for this pyplot submodule. Now that we have imported both of these libraries, I'd have to create the data. So I'll have two variables over here, x and y. And in x, I'll have a list of numbers starting from 1 going on till 10. And that I'll be creating with this np.arange method. Similarly, y will just be multiple of x, twice the multiple of x. So I'll have 2 into x. And as you see over here, 1 becomes 2, 2 becomes 4, 3 becomes 6, and so on. So when we finally have to create the line plot, I'll just have plt.plot, and inside this, I'll pass in x and y. After that, when I just use plt.show, you would see that I have successfully created this line plot. On the x-axis, I have these numbers, and on the y-axis, I have these numbers. Let me add in the next comment over here. I'll just have line plot. I'll have to start off by importing the matplotlib library from matplotlib import pyplot as plt. Again, let's just wait for a few seconds. So we have loaded this. Now we'd have to create our data. We have already loaded the NumPy library. So in the x variable, I will have np.arange, and the values will be from 1 to 11. Let me print out x. Now I'll go ahead and create y over here. So y will be 2 times of x. I will have 2 into x. And when I hit on run, this is executed. Let me also print this out. So in x, I have 1 to 10, and in y, I have 2 to 20. And to create this line plot, I will just have plt.plot over here, and I'll pass x comma y, and I'll have to show out this line plot. So as you see, I have successfully created this line plot. So this is a linear line. So as the value of x increases, the value of y also increases. Now in the same line plot, if you would want to add the title, x label and y label, that is also something which we can do. To add the title, we just have to use plt.title, and I'm giving the title as line plot. And to add the x label and y label, I'll be using x label and y label methods, and inside this I'll just pass in whatever label I'd want to give into the x-axis and whatever label I'd want to give into the y-axis. So here I'll just make in the changes. These two will be the same, and I'd have to add in the title. It'll be plt.title. I'll just write down my first line plot. And then I'd have to add the label. I'll have plt.xlabel, and here I'll just give the x label as x-axis. Then for the y label, I'll just give it as plt.ylabel, and the label will simply be y-axis. And here, as you see, I have given the title, I have given the label for the x-axis, and I have also given the label for the y-axis. Then going ahead, we are creating a bar plot using matplotlib. So first we'd have to obviously create the data, and once we create the data, we can build a bar plot, and we are creating this data with the help of a dictionary. So here I'm creating this dictionary called as student, where I have 3 key value pairs, which are basically names of the students and marks of the students. So we have Bob, Matt and Sam over here, and Bob has scored 87 marks, Matt has scored 56 marks, and Sam has scored 27 marks. Now going ahead, we'd have to individually extract the names and the values from this dictionary. So to extract the names, I'll just use student.keys because names are just the keys. Then to extract the values, I'll have student.values, and I'll convert both the keys and values in the form of a list. And this I'll store in names, and this I'll store in values. And to finally create this bar plot, I'll be using plt.bar. And as you see, this takes in 2 parameters over here. The first parameter will be the categorical variable, and the second parameter will be the numerical variable. And normally the categorical variable would be on the x-axis, the numerical variable will be on the y-axis. And as you guys see over here, I have names of the students on the x-axis and the marks of the students on the y-axis. Let me add in the new comment over here. I'll have bar plot. I'd have to create the data first. I'll give in the name of this dictionary as student. I'll give the name of the student. So the name of the first student is Matt, and let's say Matt has scored only 50 marks. Then we have Bob, and Bob has scored 98 marks. Then we finally have Annie, and let's say Annie has scored around 85 marks. Let me also print this out for you guys over here. And now that I have created this dictionary, I'd have to extract the keys and values from this. So I'll have student.keys, and whatever value I get, I will convert this into a list. And I'll store it in a new object called as names. Similarly, I'd have to extract the marks of the students as well. I'll have list student.values. And this I'll go ahead and store in a new object called as marks. Now that I have extracted the keys and the values, I can go ahead and create the bar plot. I'll have plt.bar. On the x-axis, I'll have the names, and on the y-axis, I'll have the marks. I'll just have to use plt.show. And as you guys see, I have successfully created this bar plot, and from this bar plot, we clearly see that Bob has scored the highest marks and Matt has scored the lowest marks. We have our next question. So this time we are supposed to create a line plot using Seaborn. So Seaborn is another library which is used for visualization, and this library is built on top of the matplotlib library. So if you want to work with Seaborn, then we would also need to import the matplotlib library. So we start off by importing Seaborn library, import Seaborn as SNS, then we will go ahead and import pyplot. From matplotlib, import pyplot as plt. After importing the required libraries, we'll be importing the dataset on which we are supposed to create this line plot. So in the Seaborn library, we have some built-in datasets, and one such built-in dataset is the fMRI dataset. And to load this, there's a method called as load dataset in the Seaborn library. So I'll just write down sns.load dataset, and inside this I will give in the name of the dataset which I want to load. So here I'd want to load the fMRI dataset, and I'll store this result in this object called as fMRI. Then I will have a glance at the first 5 records of this. So here, as you see, I have a glance at the first 5 records. Then I would want to create a line plot between these two columns, between the time point column and the signal column. And that is why I am mapping the time point column on the x-axis and the signal column on the y-axis. So here we have 3 parameters. Time point goes onto the x-axis, signal goes onto the y-axis, and fMRI is mapped onto the data layer. And here, if we look at this line point closely, we would see that the signal value, if let's say the time point is in seconds, so we have the seconds starting from 0 seconds going on till 17.5 seconds. So the signal value, it starts at 0 and it reaches its peak of 15 at a timestamp of 5 seconds. Then from 5 seconds to 10 seconds, there is a fall in the signal value. So from 15, we reach to around minus 0.05. So this is a very interesting insight which you were able to find out from this line plot. Now I'll go ahead and add the new comment over here, which will be cborn. I'll have to load this library from import cborn as SNS. Now I'd have to load the dataset, so I'll just write down sns.load dataset, and the name of the dataset is fMRI, and I'll store this in an object called as fMRI. Then let me have a glance at the first 5 records of it. So here I will have fMRI.head, and here, as you see, I have the first 5 records of all of these columns. So this dataset basically has the subject column, time point column, event column, region column, and signal column. And we would want to make a line plot between the event column and the signal column. Actually, the time point column and the signal column. We'll be mapping the time point column onto the x-axis and the signal column onto the y-axis. For this, I'll write down sns.lineplot. And onto the x-axis, I'd have to map the time point column. Onto the y-axis, I'd have to map the signal column. And the data which I'm using is obviously fMRI. Then to show it out, I'll have plt.show. We seem to have an error over here because the name of the column should be in double quotes. So time point will go in double quotes. Similarly, signal will go in double quotes over here. And as you see, we have created this line plot using cborn library. Then we have our next question. So this time we'll have to create a scatter plot using the cborn library. And we'll be implementing the scatter plot on top of the iris dataset. So to load the dataset, we'll be using read_csv method. So we'll have pd.read_csv, and I'll give in the name of the dataset which I'd want to load. So here I am loading the iris.csv file, and I'll store it in this object called as iris. And when I print out the head of it, we will get the first 5 records of this iris data frame. And to create a scatter plot, so we are creating a scatter plot between the sepal length and the petal length. So that is why we are mapping the sepal length onto the x-axis and the petal length onto the y-axis and onto the data layer, because we are making this scatter plot on the iris dataset. That is why we are mapping the iris object onto the data layer. And if you look at the result over here, you would see that there's a linear relationship between the sepal length and the petal length columns, which basically means that as the sepal length of the iris flower increases, the petal length of the iris flower would also increase along with it. So this again is an interesting analysis from this line plot. I'll add a comment called as scatter plot over here. And after this, what I'll do is I'd have to load up the data set. So I'll have pd.read_csv, and inside this I will pass in iris.csv, and this I will store in an object called as iris. Let me print out the first 5 records of this data frame. And you would see that this iris data frame comprises of these 5 columns. So we have sepal length, sepal width, petal width, and species. And we would want to make a scatter plot between the sepal length column and the petal length column. So for this, I will just have sns dot scatter plot, and onto the x-axis I am mapping the sepal length column. Then onto the y-axis I'll be mapping the petal length column. Then onto the data layer I'll be mapping the species object. Then I would just need to have a glance at this. So here the data is actually the iris object and not species. And we have printed out this beautiful scatter plot between sepal length and petal length. Now if we also would want to add color to this, and if we want to determine this color on the basis of a column, what we can do is, since we have one categorical column in the iris data frame called as the species column, what we'll do is we will go ahead and map the species column onto this hue attribute, which would basically help us to give different hues or different colors to the points. And as you see over here, since I have three categories in the species column, I would have three different colors. So these blue points represent all of the Setosa species. These orange points represent all of the versicolor species. And these green points represent all of the Virginica species. Here all I have to do is add in a new attribute called as hue, and I would have to map the species column onto this. And here as you see, since I have three categories over here, that is why I have three different colors.
This brings us to the end of Python interview questions. Now, before you guys sign off, I'd like to inform that we have launched a completely free learning platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. So thank you very much for attending the session and have a great learning ahead.